Hi everyone, I'm Sam McCormick, Senior Data Scientist at Mutinex, and today I'm going to walk through an example of how to use our open source MMM validation library. For this example, we'll be using Google's open source MMM Meridian. Just as a general overview of the workflow, we'll first be loading in our marketing data, we'll then be configuring our model, and then we'll be connecting up to our MMM eval library. I'll show you exactly how that works. And then we'll be off to the races, ready to run our test suite and get results. First, we load our marketing data. For this example, we're just loading synthetic data from Meridian's repository. Next, we configure our model. This is all Meridian specific. And I just want to point out that all of this logic, if you're already using an open source MMM, you'll already be doing this. There's nothing new here. Now, if you are ready to evaluate your model, or perhaps multiple models, you can connect up to our library by creating an MMM eval configuration object. We aim to make this as easy as possible by allowing you to basically just pass in your MMM, and then our library behind the scenes basically grabs all the configuration information that it needs in order to run the test accurately. So we intend to make this as low touch and integrate as nicely with your workflow as possible. You notice there's only 10 lines of code here, so you can spend less time configuring and get your results as quickly as possible. Okay, and here we are ready to run our tests. So there's two broad categories of tests to talk about here. The first is accuracy. And what do we mean by accuracy in the context of MMM? So to back up, an MMM is essentially a regression model with the target of predicting sales. Ultimately, the use of the model is usually to understand the effectiveness of the various media channels. If your model can't predict sales accurately, it essentially has no way to properly control for all the complex factors and get an accurate estimate of how important each media channel is. So that's why it's a fundamental part of our package. So to give an analogy here, imagine you, for some reason, want to measure how much space heater you have in your bedroom is warming up your bedroom. But all you have to measure it with is a broken thermometer. It's miscalibrated, and any reading it gives, is going to be off on average by 30 or 40%. Would you really trust that thermometer to give you an accurate measurement of how much your bedroom is warmed up? Of course you wouldn't. That level of error is unacceptable. That analogy holds perfectly for MMM. If you can't predict sales, there's no way that you're going to be able to deliver accurate insights about media. First test we have is in-sample accuracy, very straightforward. On data the model has seen and it's trained on, how accurately can it predict sales? Holdout accuracy or out-of-sample accuracy is when the models applied to data has not seen yet, how accurate are its predictions. And this is critical for generalization and decision-making into the future. Cross-validation is very similar to holdout accuracy. It just repeats the step of applying to data the models have seen multiple times, averaging over the results, gives you a little bit more of a robust estimate of that generalization performance. The other category of tests to be concerned with is stability tests. So the idea here is that a good MMM, if the inputs change only a little bit, the output should not change drastically. And another analogy to motivate this is, imagine you're baking a cake and you're weighing out your ingredients in your kitchen. You have a kitchen scale. You notice every time you put your hand close to the scale, the reading oscillates by 100 grams. You obviously wouldn't trust that scale to bake a cake with because it's so sensitive to things that shouldn't really matter. The same is true for MMMs. The tests we run here are refresh stability, when the model is provided with new data, and retrained, how much the historical model insights change as a result. Next test, perturbation, basically measures when I modify the input spend and retrain the model, how much do my insights change by. Lastly, the placebo test tests whether the model can correctly identify that a feature uncorrelated with sales is in fact not useful for predicting sales. I hope that was useful. This example is for Google's Meridian. We also support PyMC Labs, PyMC Marketing MMM. And the way we design our framework, it's very easy to connect up other open source MMMs as well.